Hello there. In this lesson, we're going to learn about dilution and mixing solutions. So when you are making up a solution, a piece of glassware that's really useful is a volumetric flask. So a volumetric flask is this one with the long skinny neck, and it's got this line partway up the long skinny neck, and that line is super accurate measurement of the volume for that flask. So if 250 milliliters, if you fill that up so that the bottom of your meniscus just touches that line, you've got yourself super accurate 250 milliliters, which is great for mixing solutions. So the usual way to use this is to mix up your solution in a smaller volume and then add that in, say in a beaker, so you have the right amount of solute in already dissolved, and then you dilute it up to the line there, so then you get your really accurate solution with the concentration that you want. So there's a neat relationship between the concentration of a solution before more solvent is added, and then after you'll get a new concentration. And the relationship is the concentration times the volume before is equal to the concentration times the volume after. So a little 2 and the 1, that means the 1's refer to before and the 2's refer to after. Okay, so the reason why this formula works is that the concentration times the volume will give you moles of the solute. So concentration will be in like moles per liter, and the volume will be in liters, and that's going to give you moles of solute. So the moles of solute before is going to be equal to the moles of solute after, right? Moles per liter times liters equals moles of solute. So you can kind of visualize this if you think of the solute particles as being like these dots, 6, 7, 8, 9, 10. If I got 10 of them in there before, and then I just add like more solution, more water, sorry, more solvent, then you're still going to have those same 10 particles. They're just going to be spread out from each other. Did I get 10? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah. They're just going to be more spread out from each other, and that makes it a more dilute solution. So the relationship works really well because all you need is the concentration of the volume, and then the volume change you can work out what the new concentration is, or you can work out how much volume you need to add to get a specific concentration. Alrighty, so let's try this out. It says, what is the new concentration when 50 milliliters of water is added to 100 milliliters of this concentration of solution? So this is the initial volume, and this is the starting concentration. So we got C1V1 equals C2V2. And then we added a 50 milliliters more water. So the new volume is going to be the 100 that we started with plus the 50 that we added. So V2 equals 150 milliliters. So now we want the new concentration, that's our C2, and we can rearrange this to give us that. C2 equals C1V1 divided by V2. So that would be the initial concentration, 0.75 moles per liter, the initial volume, 100 milliliters, divided by the final volume, 150 milliliters. Now I could have changed that into liters, but you see how they divide out. So if I did, it wouldn't matter because the units just cancel anyways. So let's see what that comes out to. 0.75 times 100 divided by 150 equals 0.5 moles per liter. That's our new concentration. All right, in our second problem here, we're given initial volume again, same initial volume, same initial concentration, only this time we want to add water in order to get to this new concentration that we're hoping to make. So we can use the same relationship, C1V1 equals C2V2, in order to work out the missing value, which is the final volume. So V2 equals C1V1 divided by C2. And so the initial concentration is 0.75 moles per liter. Initial volume is 100 milliliters. And the initial the final concentration we're looking for is 0.25 moles per liter. So the final volume is going to be should be 300 if I'm not mistaken. So 0.75 times 100 divided by 0.25 equals, yeah, there it is, 300 milliliters. So that's the final volume. But the question didn't ask me what the final volume. It asked how much do I need to add. And so if the final volume is 300 milliliters and we started with 100 milliliters, so volume added equals 300 milliliters, which is the final, minus 100 milliliters, which is the initial. And you'll end up with 200 milliliters, which is the difference. And that's how much you have to add. Okay, this next one's a little trickier because it involves looking for a concentration of ions, and you start with a concentration of the whole compound. And you can see that there's 2 chlorine ions in this compound. Okay, so we're going to use that same relationship, but we're going to have to do an extra step to get to those ions. So we have 100 milliliters again, which is our V1. We have our initial concentration, which is C1. And we're going to add 400 milliliters of water. So our V2 is going to be the 100 that we started with plus 400. So V2 is going to be 500 milliliters of water. So let's look for the concentration then. So C2 equals C1 V1 divided by V2. And that equals 0.75 moles per liter times the initial the initial volume divided by the final volume, which is the 500 milliliters. So let's see what that comes out to. 0.75 times 100 divided by 500 equals 0.15 moles per liter, and that would make magnesium chloride. Now, if you want to get to the concentration of chlorine, we got to multiply by the number of chlorine ions for every magnesium chloride, and there's 2 of them, right? So to finish this off, we're going to multiply by 2, and we'll end up with 0.30 moles per liter, and this time it's chlorine ions, because these 2 will cancel out. Okay, our last situation here is what if we have 2 of the same solution and then we mix them together? If we take 2 salt solutions or 2 acid solutions and we pour them together into the same beaker, what happens to the concentration then? Well, conveniently, because there's moles here and there's moles here, and you pour them into the same container, it's going to be total moles here. Well, you can figure out that the moles after is going to equal the sum of the moles before, right? This is moles, this is moles. Call this 1, call this 2, after will be 3, right? So moles 1 plus moles 2 equals moles 3. Make sense? Okay, let's see if we can use it to solve this little problem here. What is the new concentration of sodium chloride if this solution is mixed with that solution? We got the 1 here and we got the 2 here. So C1V1 plus C2V2 equals C3V3. All right, so C1 and V1, concentration is 0.50 moles per liter. The volume is 100 milliliters. Change it to liters if you like. Plus C2, 0.30 moles per liter, times the volume is 400 milliliters. And C3, we don't know, but we do know what the final volume is because we added 100 milliliters to 400 milliliters. So that's 500 milliliters as the total volume. So there's only one that we don't know here. And we can divide both sides by this 500 milliliters. We'll be able to find our answer. Yay! Okay, so let's see what it comes out to. 0.5 times 100 is 50. 0.3 times 400. 0.3 times 400. I can't do that one in my head. 120. Maybe you can. And we'll divide that by 500 total. So 120 plus the 50 equals 170 divided by 500 equals 0.34. 0.34 moles per liter. Yay, crowd goes wild. Okay, our last one is an Uber challenge. This time we're looking for how much of one solution we'd have to add to another solution in order to get a final solution that has a specific concentration. All right, so let's set up our formula here and see if we can use it to solve this. So we got C1V1 plus C2V2 makes C3V3. All right, what do we have here? C1V1 said what volume of 0.35 molar, so 0.35 molar, but V1 we don't know. And then C2V2, we know both of these, so it's 0.50 moles per liter, and it is 100 milliliters. C3 we know is going to be 0.4 moles per liter, and the volume is going to be the sum there. It's going to be 100 plus whatever V1 was, right? We're just going to add these two volumes up. So this is just a little bit of algebra here now, right? What you'll need to do is, expand this out because the 400 is going to multiply for both of those, right? Or the 0.4. So 0.4 times 100 is 40, and then it's 0.40 V1. And then over here, 0.5 times 100 is 50, and then here 0.35 V1. And so we can put these V1s together on the same side. We'll move this one over there. So it's 0.4 V1 minus 0.35 V1. And that's going to equal 0.05 V1. On this side, we're going to move this guy over this side. So 50 minus 40 equals 10. And then for V1, we will divide both sides by 0.05. And what you'll end up with is 10 divided by 0.05, which is 200. So there you go, little algebra, and you figure out finally that 200 milliliters of that 0.35 molar HCl is needed. Yay! Okay, hope that helps. See you soon.